Hello everyone. In this video, we will discuss another exercise on if statements. As we said, this programming construct is very important and it's really essential to have more practice on it. So let's see. The problem says, write a MATLAB script that reads the numerical grade of a student and assigns a little grade to it according to the following schema. The schema is as follows. If the student's grade is greater than 95, then the grade is A. Between 86, greater than 86, equal than or less 95, it's P, and so on all the way to the F. Okay? So obviously there is a branching here, and we will need to use an F statement. So let's get just things starting. You'll open a new script. We'll save this and call it grades underscore f dot m. And yeah, so the first thing is just to receive the grade of the student. We can define this as a variable x or grade or anything. So let's actually call it grade. So grade equal input. And the input is enter the grade. So as simple as this. And then we will start the branching. So if grade, obviously there is an F statement and there is an N. If this grade is greater than 95, then what's going to be displayed on the screen, let's say, um, um, we can make it this really simple here. Just display A, as simple as this. Of course, we can be more, informative by saying that the letter grade is A. Let's actually do this. The letter grade A, or we can, take a shortcut as we did previously. All right. So let's go with the long description. And then what? And then else if. Now, here is something that we need to be a little bit careful about, which is how do we write the condition uh, greater than 86 and less than 95? So someone might say, okay, that's easy. Let's do, basic mathematics. So it's 86 and grade and, less than or equal 95. But there is really a big problem here. And we have to explain this on the side uh, because this expression is completely wrong. So let's see why this is completely wrong. Suppose the student's grade, just let's do this analysis here. Suppose the student's grade is, maybe maybe 70. Okay, so obviously 70 is not in this range between 86 and 95. But what's gonna happen in this case? So MATLAB is trying, remember, this is not mathematics, this is programming using MATLAB. So 86 less than 70 less than 95, less than or equal. And you want MATLAB to judge whether this statement is false or true. In the hierarchy or the order of performing the relational operators, things go from left to right. And as such, we will have the comparison 70 greater than 86. It will be evaluated first, and the answer is false. Now, false less than 95. When there is a relational operator, in this case between a numeric and a logical data type, the logical will be converted into a number, and that number is 0. So it will be 0 less than or equal 95. And in fact, this is true. So surprisingly, MATLAB will judge this statement as true. In fact, let me tell you something. Whatever number you put for the grade, whether it is greater than 86 or less than 86, the answer will always be true. Because even if you take a greater number, let's say you take 100, so 100 is, so let's actually analyze this here. 186 less than 95. Now, when you evaluate from left to right. When you evaluate this first, it will give you true. So this is true, less than or equal 95. But again, true will be converted into 1. And 1 is less than or equal 95. So MATLAB will tell you that this is true. Let's actually even test this here. Let me ask MATLAB whether 86 is less than 70, less than or equal 95. MATLAB will tell me, yes, this is true. Although we know from mathematics this is wrong. Similarly, if I ask MATLAB 86 is less than 100 is less than or equal 95, again, it will tell me this is true. So how do we code this? The correct way to code this is using AND. So one way to do this is to say, look, no, this is not correct. If the grade is greater than 86 and the grade is less than or equal 95, then in this case, I will display on the screen the letter grade is B. Okay, so you need the AND here, the AND operator. You cannot do this using similar writing in a way similar to mathematics. It just doesn't work in programming. And then we continue in a similar fashion. I think it's straightforward. In fact, I can copy this block because it will make things a little bit faster. I can make also more space here, so that we see what's going on. So let me copy this again, indent it correctly. The next interval is between 76 and 86, and the grade is C. Similarly, there is another interval, so there is else F. The grade is, so let's see, if it is greater than 66 and less than or equal 76, then the letter grade is D. And then there is the last resort. The last resort here, larger, the last resort here is the following. I have to be careful here because also someone might give me weird numbers. So I shouldn't use else alone. Maybe I should still use a range. So again, else F, the grade is between 0 and 66. Then the letter grade is F. Let's actually test this code. Usually the connecting points, the points at the boundary between two letter grades are the problematic ones. So let's actually enter a letter grade. Well, let's give a student 100. So the answer is A. Let me do CLC and try another student. Let's give a student 95. So that's a borderline case. The student gets B correctly. Let's test a student that gets 66 exactly. So that student gets F. So it seems that the code is working. So this is one way to address this question. There is in fact another way, and the other one is a little bit more concise. So what we have done here is great, and probably this is from a readability point of view is the best. There is another way to solve the exercise in a concise fashion, basically changing the conditions a little bit. So the first one will remain the same. But for the second one, I really do not need to check that it is greater than 86 and less than 95, or less or equal than 95, because automatically, if I passed the first check and the answer was false, then automatically it's guaranteed to be equal than or less than 95, right? Because if it was greater than 95, the letter grade would be A. So in a sense, I actually don't need this. I don't need, so I can comment it out. All what I need to know is to check that the letter grade is greater than 86 because after passing the first statement or the first condition, it is guaranteed to be equal than or less 95. In a similar way, I don't need this one. So if the grade is 76, then automatically that's fine, because since I passed this and I passed this, I know I am less than or equal 86. And in a similar way, I don't need this guy. And in a similar way, I also don't need this guy. So let's actually test that this works nicely. Again, let's test the border cases. Let me give a student 66. That student should get an F. That's actually correct. Let me test another border case, 86. So the answer should be, according to the schema here, 86. So let's run this again, and the student correctly gets it. So you see, I personally prefer the ampersand, the double ampersand, because from a readability point of view, it's easier for the eye. In fact, it's very consistent with the math writing here. The math writing itself cannot be used directly as a programming, because as we demonstrated, this is very, very problematic. While what we have done here is too concise, I don't think it's computationally more efficient or anything, simply because the double ampersand works in a short circuit fashion. So, if the first statement is false, automatically it's known it's false. It only needs to check, well, maybe I should change my mind. No, because if the first statement is true, it needs to check the other one. So, no, I take my word back. In fact, the double ampersand would be computationally a little bit more expensive. So this is more concise, and it's faster. But from a readability point of view, I don't see it's easier to read, but it's easy to understand. All right, thank you so much, and see you in another video.